All right, in the previous video, we learned all about the history and development of the periodic table, and here we're going to dive into it and talk about the groups of the periodic table. All right, so it's really best if you actually take your periodic table, um, take it out, and write the titles of each of the groups, which are going to be the columns on the periodic table. Okay, so group one, everybody in the first column are going to be called the alkali metals. Okay, alkali is another word for base. All right, so this is the basic side of the periodic table. Everybody in group one is going to end with an S1 electron configuration from the previous chapter. Okay, because they have this one extra electron. And because of that one extra electron, they are going to want to get rid of it. Okay, they're going to want to donate it. They're going to want to be nice and stable like our noble gases. Everybody wants to be like a noble gas. So what does that mean? That means that in their elemental form, they are going to react violently with water. They are going to turn water into a basic solution. So if you have sodium and it reacts with water, it's going to give off hydrogen gas, which is explosive, and it's going to make sodium hydroxide, which is Drano. All right, it is definitely not going to be a pleasant situation. In class, I show the Brainiac video about alkali metals and water. Um, Mythbusters kind of busted them a little bit because the explosions for the elements down at the bottom of the periodic table that they did, like they did rubidium and they did cesium, and they were like, these guys are really uh, dangerous. They weren't actually as dangerous as they made it seem, but it's still pretty nasty. But it's a very fun video to watch anyway. All right, so we're talking lithium, we're talking sodium, we're talking potassium, rubidium, cesium, and francium is really rare and radioactive, so we're not going to blow any of that up. Okay, but it's literally going to have fire on top of the water. Okay, group two are called the alkali earth metals. Okay, these are much more earthy, much more calm. These are the much calmer cousins. These have a full S2 configuration, and they are actually very common in dirts and rocks. They are the Earth's surface. Um, they make water as a base, so we're talking our beryllium, magnesium, calcium, strontium, barium, radium, um, and these are the safer alkali metals, the alkali earth metals, and this is what we use in like an Alka-Seltzer and Maalox and Tums and Rolaids. There's like calcium carbonate in there and milk of magnesia. All right, they use I think it's a magnesium carbonate, something like that. So these guys are used as bases um, or antacids in order to calm down your stomach acid when you've had too much spicy or rich or garlicky stuff. Okay? The middle of the periodic table, these guys right here, these guys are known as the transition metals. They all have a D electron configuration. Those are typically what we refer to as the common metals. So most of the metals that you have um, heard of before and seen before are all going to be here. Um, like your chromium is over here, and your iron, your copper, your zinc, silver, gold, mercury, uh, and we go on and on and on and on about all these different. Nickel is up here, cobalt. So lots of these elements that we've already seen, heard, and are fairly common and useful. Here we have the lanthanide series and the actinide series, or sometimes known as the lanthanoids or actinoids. They are called inner transition metals, this F block right here, because they go into the transition metals. Get it? Inner transition and transition. Oh, look at that. It's amazing. Right? So these guys go in here. Um, and this is where we start seeing some of the really large elements. Down here in the actinide series is where we're going to see a lot of the radioactive stuff, the thorium, uranium, curium, named after Marie Curie, and californium, and einsteinium, etc., etc., lawrencium, which is our last naturally occurring one of three, not one of four, like in the previous video. I said it wrong. Um, but yeah, so we will definitely be talking about this part of the periodic table a little bit more. Groups 13 to 16, which have the P1 to P4 configurations over on the right-hand side. So we're talking like these right here. Um, those are either going to be metals, metalloids, or nonmetals, depending on what side of that line of demarcation that we're talking about. So, these guys would be the metals, these would be the nonmetals, and the metalloids would be right in the middle. Group 17, which is the second to last group, are your halogens or halogens. They are the P5 configurations. They are also very highly reactive. They need one more electron to be completely full like a noble gas. Fluorine, chlorine, bromine, iodine, and these are also very highly reactive. That's why the chlorine tablets will do such a great job at disinfecting things, and why we use iodine on skin before medical procedures. Some of them are found in different halogen light bulbs or in the lamps. They have that like bluish tint to the higher end cars that have the halogen light bulbs in them. But a lot of times, group 1, which is your alkali metals, and group 17, which are your halogens, react together and basically calm each other down. So you can get something as simple as salt from them. And then lastly, we have our group 18, our noble gases. These guys all have a P6 electron configuration. They are all gases. They are like the nobles. They do not react or combine with other elements. Everybody wants to be like them. The Hindenburg, which was a Nazi blimp, Hindenburg, used hydrogen because they had an embargo placed against them for their awful activities. So they crossed out and they weren't available to get any helium, so they used hydrogen instead, and that is flammable, violently reacting. But things like the Constitution and the Mona Lisa are all behind very thick glass, and it has argon gas in it, and helium-filled balloons and neon lights. All of this stuff is very um, important to keeping these artifacts and things safe. And you wouldn't want anybody to get in trouble or hurt blowing up any kind of balloons. And then this website right here, our interactive periodic table, I have linked for you, and you can go on and see the different groups, and you can click on something like fluorine, and you can see fluorine come up with all of its uses, and we have lithium, and you can see what gallium is used for, neon, um, and it's a very nice little interactive thing that you can really identify what we're doing in our periodic table. Okay, so the next section really just reviews what we did in the previous chapter. So I'm just going to go over that really quickly, and that is that block diagram and how each part of the periodic table is done this way on purpose. And you have your first layer of S and your second layer of S, 3S, 4S, 5S, 6S, 7S. Here is your 2P, 3P, 4P, 5P, 6P, 7P. And then for the D block, remember we subtract 1 from the row. So if this is the fourth row, this is 3D, 4D, 5D, 6D. And then for the F block, we subtract 2 from the row. So if this is the 6th row, this is 4F and 5F. 4F, 5F down here. So things that we have seen before in our previous chapter. And as you go through, it has this reoccurring properties over and over and over again, which is really kind of amazing. For what we're going to do for the rest of this chapter, though, we are really only going to look at the group A elements. The group A elements are known as the representative elements, and they are much more predictable in their patterns. So that would be the S block and the P block, the salt and pepper block. So that means we're really only looking at this and this part of the periodic table. The group B elements are going to be your transition metals and your intertransition metals, also called rare earth. So we're not going to look at them as much because they have these really complicated d orbitals and these huge shapes, and we're not going to really see our patterns as clearly. Okay, so when we're going to talk about these, we're really going to talk about columns 1 and 2 and 13 over to 18. All right, so trends are coming up.